In this video, you're going to learn how to find an estimate for the median as well as the upper and lower quartiles, which you can then use to find the interquartile range. In this example, you're given a histogram and you're asked to find an estimate for the median. We can't actually find the exact value because we're not given the exact data, we're just given a range of data by looking at our histograms. So that's why it's called an estimate. You can get asked actually why it is an estimate. To start off this problem, we're actually going to build our frequency table. So again, you look at the histogram and say, well, the first bar is from 0 to 20, and then 20 to 40, and so on. And you need to actually find the frequencies. Remember, that's just by doing the class width times by that frequency density. So our table will look like this. Next, we're going to just add up the frequencies to find our total frequency. This is needed because that position the median is in is going to be n plus 1 divided by 2. That n value is your total frequency. So in this case, it's 150 plus 1 divided by 2. So we're looking for the 75th and a half value. We're now going to use our cumulative frequency to figure out which interval would contain the 75th and a half value. To do this, we need to say, well, our first one contains the first 30. Then we're going to add on the next one to get to 72. We still haven't reached it yet, so we're going to add on another one, and we have finally made it. Because we passed 75.5 in that third interval, it means that our median is going to be somewhere between 40 to 50. So we're looking at that interval from 40 to 50 now. We're trying to figure out how far into this interval we're going. So that's really like creating a new class width. To do that, you'll need to find the frequency as well as the frequency density. So first, our frequency is just found by finding the difference of our median position and how many values had been used before our interval started. Next step is to look at the frequency density. Now you actually have to go back to the histogram for this. I don't have any room for it right now, so I've looked back on it myself and seen that it's 2.5. Again, that's just by looking at the bar for our interval from 40 to 50. Using our frequency density triangle, we can see that the class width is just the frequency divided by the frequency density, and in this case it gives us 1.4. Now that means it's 1.4 more than our lower bound of our interval. So in this case, 1.4 more than 40, which means our answer is 41.4. I'd like you to go ahead and pause the video now and actually try and estimate the median for this new histogram that you're looking at. I realize it takes a lot of steps, but go ahead and try and work through it. If you need to go back to the example, go ahead and then hit play when you're ready to go over the answer. Alrighty, let's go over the answers now. So first we're going to fill out that frequency table. This just helps us keep it organized. So our intervals come from the widths of our bars, and then our frequency comes from multiplying the width by that frequency density. Now we can consider our total frequency. Remember, that's just found by adding them all together. So our total frequency is 740. To find the median position, we're going to add 1 to it and divide by 2. So we're looking for the value that's in the 370 and a half value. Now is where our cumulative frequency comes in handy. We're going to find it until we pass 370.5. Now I've actually filled out the whole table, but you actually don't have to once you've reached a number more than 370.5, which in this case is in the interval from 60 to 100. Next we find our frequency. So to do this, we're going to take the median position and take away the number of values that we've already used. So 370.5 and take away the 120 that were used before our interval. So that means our frequency is 250.5. Using the histogram, we can figure out the frequency density for our interval is 6.5. That means that the class width is just 250.5 divided by 6.5, and we get about 38.5. That's the one decimal place. We're finally at the last step. So that 38.5 is saying that we're 38.5 into our interval, which started at 60. So it's just 60 plus the 38.5, which means our median is estimated to be 98.5. Now let's go through an example of finding the lower quartile. Now we're going to look back at the exact same histogram that we saw on the first example. So that means we already have our frequency table made. The only difference between finding the median and finding the lower quartile is that to find the lower quartile, it's the n over 4th value. It's not n plus 1, it's just n over 4. The rest of our steps actually are the exact same. This means that our lower quartile will be the 150 over 4th value, or the 37.5 value. So we're going to use our cumulative frequency, and we'll find out that it is in the interval from 20 to 40. We need to find our frequency by doing the 37.5 and taking away the 30 values that were used before our interval, so our frequency is 7.5. Next, we can look back at that histogram and look at the bar from 20 to 40, our interval, and see that the frequency density is 2.1. Now to find the class width, we will just do our frequency and divide it by our frequency density, and we end up getting 3.57 to 2 decimal places. The last step is just to say, well, that's how much more it is than our lower bound, so it's 20 plus 3.57 to get an answer of 23.57. Now let's look at the exact same histogram again, but we're going to find the upper quartile. So again, the exact same steps, but instead of just being n over 4, it's 3n over 4. So our upper quartile will be at the 450 over 4 value, or the 112.5 value. Now we're going to use our cumulative frequencies, keep adding them on until you pass 112.5, and in this case, it's going to be in the interval from 50 to 60. Now we're going to find the frequency, so remember this is just saying the 112.5 value, and take away the 97 we'd already used, so we're looking at 15.5. The frequency density again is just found by looking at the bar in the histogram for the interval of 50 to 60, and we find that it is 2.9. We'll find the class width by just doing 15.5 and dividing by 2.9. That means our class width is about 5.34. Again, to actually find the upper quartile, you're going to add it to the lower bound of our interval, so 50 plus that 5.34, which means our upper quartile is 55.34. Another thing that you can be asked from a histogram is to find an estimate for the inner quartile range. Now with this, you are supposed to find the upper quartile and find the lower quartile, and then just find the difference. But we've already done that, so we just have to find the difference of them, and we find our answer is 31.77. Go ahead and pause the video again. You're going to find an estimate for the inner quartile range, so that actually means you have to find an estimate for the upper quartile and the lower quartile, and then just find the difference of the two. So when you're done, press play again, and we'll go over the answer. Hopefully you noticed that this actually is the same histogram that you were using before, so our frequency table is already done for us. Now to find the lower quartile position, you'll just do the 740 and divide it by 4. That means we're looking for the 185th value, and in this case it's in the interval of 60 to 100. The frequency is found by doing 185 and taking away the 120 that were used already, so it is 65. Next, we'll do the class width of 65 divided by its frequency density. That's 6.5, found by just looking at the bar. So we have a class width of 10. So we'll just add that onto the lower bound of our interval, and we'll get 70. Now on to finding the upper quartile. So again, that's going to be 3 times 740 and divided by 4. And we get that we're looking for the 555th value. This is going to be in the interval from 120 to 140. So we can find our frequency next. The frequency is just the 555, take away the 540 that we'd already used, so our frequency is 15. Our frequency density is just 7. We just find it by looking at how high the bar goes from 120 to 140. Then our class width is just 15 divided by 7, so it's 2.14. This then means that our upper quartile is just 2.14 more than the 120, that lower bound of our interval. So our upper quartile is 122.14. And our last step to finally get to our answer of estimating the inner quartile range is just to find the difference of those two values we just found. So 122.14, take away 70, and we get an answer of 52.14. You are finally done. Alright, that's all for this video. I know that this is a tough topic, so if you do have any questions, then post a comment on Show My Homework, or you can email me, and I will get back to you as soon as I can. Thank you for working so hard. You're doing great.